Right. So I do apologize. I did not explain to you why we calculate stresses at point A earlier. Okay. So I'm going to, before we do stresses at point A, I'm going to tell you why we're calculating at point A. So if we look at how our structure is loaded, right? So now we are going to focus on the brass, the material number 1. I'm going to highlight where we're going to focus on, right? And we have found that our centroid, then our centroid, right? So we know that we have a moment about Z doing this. This is in compression. This is in tensor. And then we have a moment about Y doing this. Okay. So this is compression. This is tensor, right? So if we were to pick 2 points, okay, we pick over here point A, and we pick point B over here. Why I pick these 2 points only for the analysis? Because they have the what? This is going to be the Y max. And for both of them, this distance from here to here is going to be the Z max. Okay, distance further away. Because the formula that we're going to apply, stress X is equal to Px over whatever E2 over E1, A1 plus by A2. Right? Plus minus, so we have N My over Iyy multiplied by Z plus minus N Mz over Izz multiplied by Y. Now we are aware that if we look at all these values, so if we look at point A and then we look at point B, right? The Px is always in tensile already, so this is in positive, right? And now if we look at My, right? If we look at My now, right? We focus on My. Point A will be tensile. Point B will be what? Compression. And Mz, both of them will be in what? In tension. So the position where maximum stress will occur, right, will be at point A. Can you see this? Right. We just focus on the brass. So that's why the next step, right? So from here, we know we are going to focus on stress X at point A, which we focus on brass, right? So the axial load for brass is 0.707 times 10 to the power 6 positive, right? Plus N is equal to 1 because the reference material is brass. My is 375. Divided by Iyy. Our Iyy was what? We found our Iyy to be 2.859 times 10 to the power minus 6. As I said, the next thing student will get wrong is this Z distance over here. So we know our transformation that this is Y and this is Z. So Z relative to the centroid is 0.15 divided by 2. Okay. So the next one, N again is 1. Moment about Z is equal to 16.936. No, 17.936. 17.936. Then multiply by the Y distance, right? So Y distance is the centroid distance. So the centroid is 123.207 times 10 to the power 3. And then we divide by IZZ. So IZZ, we found that out. IZZ is equal to what? IZZ is equal to 65.694. 65. Okay, so this is positive 0.707 times 10 to the power 6 plus by 375. 15 divided by 2 divided by 2.859 power minus 6 is equal to 9.837. Now in your term test, okay, I hope you'll do it this way because I give you part mark. If you got this correct, I give you 0.5 marks. If you got this correct, I can give you 0.5 marks. Then plus by the last term, if you got it correct, I can give you 0.5. Are we clear? Okay. If you put all of them together and just one answer, okay, I cannot give you part mark. Okay. 1 times the 17.936 power 3 times 123.207 power minus 3 divided by 65.694 power minus 6 is equal to 33.638. Okay, so usually what I do, I will write them in red. This is worth half a mark. This is worth half a mark. And this is worth half a mark. Okay. Then I can give you part mark. So this will be equal to 0.707 power 6, 9.837 power 6 plus the 3.638 power 6 is equal to 44.182 times 10 to the power 6 Pascal. Okay. If we were to just calculate stress X at B, you will have positive 0.707 times 10 to the power 6, and then you will have minus 9.837 times 10 to the power 6 plus by 33.638 times 10 to the power 6. This will be equal to 0.707 power or 44.182 minus 9.837. It will be 34. Hey, wait. 0.707 plus by 33.638 minus 9.837 will be equal to 24.509. Why 24? 0.707 power 6 plus 33.638 power 6 minus 9.837 power 6 with 24.508 times 10 to the power 6 Pascal. Okay. Wait, 0.707 plus 9.837 plus 33.638, 44.182. Okay, right. So this is that's why we calculate the maximum stress at stress A. Okay, we're going to do the same thing for steel. Now, for steel, it's a bit more not difficult, more steps to take. Okay, and now I'll show you what is this more steps to take. So for steel, right? Right. So steel, again, I'm going to sketch the centroid. And before I go on, I did for brass, I did not consider point C over here and point D because the Y distance is not the maximum, right? The Y is smaller, right, than Y max. So don't waste your time considering point C and point D. Okay, you consider the extremes. Okay. Now, on the other point, if we now look at steel now, okay, that's where we have to be careful. So now we are going to focus on our steel. Right, so I'm going to sketch out the centroids. And we know that this is our moment in Z. It's in this direction. This is our moment in Y. Okay. And then we are going to call out, I'm going to draw out 4 points, 4 points. This is our I, point I. Over here, point J. Okay. Over here, point K. And over here, point L. Okay. So we have the first one is points, right? I, J, K, and L. So if we look at the axial load, which is Px over this one is in fact E2 over E1 A1 plus by A2, right? All of them have the same value and all of them are in tensile positive. The values are all the same. Okay. Now, if we look at N, My over Iyy multiplied by Z, so we are looking at moment about Y, right? So we know that this is in compression, and this side is in tensile, right? So you know that I is in tensile, so it's positive. J is in compression. K is in compression. L is in tensile, right? So now you ask me, Eugene, which point will I have a higher stress? Can't tell yet, right? Because you have tensile. If you look at K, or you look at I and L, right? They all have tensile, but L will have higher because the distance is further, right? The distance is further. Okay. So if you were to write in tensile, this is the max in tensile. Okay, this is the maximum in compression. I and J will not be maximum because of the oh, maybe I'm wrong. Hold on. We're looking at My now, moment about Y. Okay, so moment about Y, we have to focus on the Z distance. Okay, you have to be careful down here. So if we were to focus on the Z distance, yeah, it is okay because the Z distance for K and L or I and J are the same. Okay, so there's no concern. In the other direction, then there's an issue. Let me elaborate. Okay, so you have N mz over izz multiplied by Y. Okay. So if you look at I now, right? So over here, you have tensile. And now we have compression. Okay. So I and J will be in tensile. Right. And then K and L will be in compression. So if you look at I and J in tension, the y distance are the same for I and J, so it's okay. So the values will be the same. K and L again, the y distance will be the same. Oh, so it's okay. Okay, for this case, it's okay. Everything seems to work out. So if you look at all this now, right? You look at all these points. So we know that maximum tension will be at point I. And then we also know that maximum compression, right? We know that maximum compression will be at point K, right? Because this is negative, negative, this is positive, negative. So K will have the maximum what? Maximum compression, right? So the question asks for maximum stress. Okay, down here you have tensile compression.